Good afternoon. I hope you all had a good lunch, either at the Women in Technology lunch or the main lunch, or somewhere out eating good barbecue, which is something I hope to do while I'm still here. So this afternoon we have a network automation focus, and our speaker for this tutorial will be Jeremy Schulman, who works for MLB. I understand he does not know all the star baseball players, so you can ask, but anyways, he's going to learn about network ready for use test. He's going to teach us about network ready for use testing, which is something I'm fascinated by, so I'll be sitting and watching the whole thing too. Jeremy?
Thank you. Thank you. Thanks everybody for joining after lunch. This is a tough slot, and we've got 2 hours together. So everybody settle in. What I'm going to do is show you something we built at Major League Baseball to help us through a project. So we use the term network ready for use, and this approach uses an open source piece of software called PITest. I'm going to show you what we did with it. Just a little bit about me. I've been in the networking business for 20 years, mostly on the vendor side. So I am now heading up network automation at Major League Baseball. It's the first time that I've been on the customer side, which is really great because now I get to go to all the fancy dinners and not pay for them. I've been exclusively focused in the area of network automation since 2012. I happened to have been at Juniper Networks at the time and got to do some really amazing things and really started looking at how can we take the tools that the server and now DevOps people use and apply them to networking. I'm 100% focused on network automation. I don't identify as a network engineer. I'm not a network engineer. That's too hard for me. I'm a software engineer. It's a lot easier than being a network engineer, trust me. I do a lot of open source and community stuff. I really love doing this type of thing, so thank you, Nanog, for having me, and many thanks to Major League Baseball for letting me be here. What we're going to cover in this tutorial, everything that I'm going to show you is available on GitHub, so you can always go back and play with this. In fact, my hope with presenting this information to you is not for you to understand all the things that I'm going to talk about, but it's just to get you interested so that you will spend some time and play with it. And I hope that I've made the tutorial information on GitHub accessible so that you have an easy time using it. But I'm going to go through all of the things so that you can hopefully have a good time with it. I'm going to talk about what I mean by network ready for use. I'm going to talk about some general testing concepts. I'm going to focus a lot on using PITest as a tool. And I'm going to be doing a lot of live coding. So if you are new to the world of Python, then you're going to see a lot of Python. If you're familiar with Python, then you're going to see some really interesting stuff with Python. If you have questions, I'm going to take like little breaks in between. So we're going to do a little bit of slides, a little bit of coding, a little bit of slides, a little coding, just to break it up. And if you have some really poignant questions you'd like to ask, please do. Or if you'd like to hold them to the end, I'll try to save time. So about you guys, I'm hoping that some of you have experience with Python. Just by a raise of hands, how many people have been working with Python for over a year? Okay, so for the people who can't see the audience, that's probably 70% of the audience. How many people have been working with it for over 2 years? Okay, maybe 50%. Over 3 years? Okay, now we're getting down into the teens. Okay, how many people are familiar with PITest, have used PITest? Okay, so a good number of people, not the vast majority. So this will also be a little bit of an introduction to PITest and what we do with it. I'm presuming most of the folks here are network engineers who are working on automation projects, but how many people here are software developers working with networking teams? Okay, so there's about maybe 10 folks here. That's really encouraging. I think we're going to see more and more of that over time. I'm very encouraged by that. Okay, about PITest. PITest is an open source piece of software that software engineers use primarily to unit test their software. So if I write code and I want to test my functions before I put it to production, I would use this code to test my stuff to make sure that it works before I hand it off for use. We are not going to use it for that purpose. We are going to consider our network as the code. You hear the term infrastructure as code a lot. So we're going to think of our network as code. We're going to treat it as such, which means we're going to test it. And what we're going to test is the operational states of our network. So most of the talks that I've seen for network automation have to do with configuration management. That's great. It's important. This is not that. We're not going to be talking about any configuration management. This is all about the operational state of the network, and I'll get into the details of what that means. So when I talk about network ready for use, what we're really trying to capture is, does the network operational state meet the desired outcome of the design? So normally you would have this workflow pattern of, I'm going to design a network, or I'm going to design some kind of change that I want to make to the network. I'm going to build that change. I'm going to make a configuration change. I'm going to push that configuration change out. And then I'm going to run some tests to make sure that the resulting state of the network is as I expect it to be. So maybe you're making a routing change on one router, and then you go and you look at the 5 other routers to see, did that route propagate? So when I talk about operational state of the network, what I mean is did the route propagate, for example? Like, do I see it where I expect to see it? And in order to understand if our job is done as a network engineer or our change is complete, we want to have some confidence that everything is working as we expect. And so as part of this validation block, we run what is called network ready for use. And so that's just a term that we use. I think other people might use that term. Has anybody heard network ready for use as a term? Okay, so it's not a very popular term. I heard it because we actually asked a vendor to quote us software to build, to do what I'm showing you, and they use that term. So I like that term. So I'm going to talk about what we did at Major League Baseball. We are moving into a new building. It's very shiny. But we have 2 offices, and we're moving into one new building. And that one new building is multiple floors, like maybe 6 floors in this new building. And we have hundreds of pieces of equipment that we're putting into it, hundreds of switches that we're putting into it. All different types of models. They do different types of functions in our network. But what makes it very challenging is that in New York, the only people that can actually do the installation are the union folk. So we have one group of people that is physically installing the racks, another group that is physically installing the switches and power, another group that is running cabling, and then depending if we're going through different rooms or different floors, we have all this other different cabling. And so while this is a greenfield environment, what we're really doing is we wanted to be able to audit, did the installation team do their job? Like when they say they're done, they said, yeah, we set up MDFA and that room is done. Since we didn't install it, we need to know, did they do it right? Is it cabled correctly? Did they do their job? Is it actually done? And if it isn't done, how can we pinpoint where the mistakes are so that we can give them information so they can go fix their problems? So we broke this up into 2 phases. The first phase was specifically and only on the physical layer, meaning, did we have our devices on net, meaning when they plugged them in and turned them on, did we see them on our management network? Could we onboard them into our management platforms? Were the optics installed properly? And was cabling installed properly? Meaning, did they cable things together correctly? Now, as kind of basic as this might sound, this was a really interesting use case for operational state because it had nothing to do with configuration management. And there's nothing on the box, quote, configured that we could use to know whether or not they did the job right. We had to have this set of information that we knew what it was supposed to be based on our design. Like we knew that these types of optics had to be long range versus short range, et cetera, et cetera. We knew what that was. So when we would say that they were done, it was a function of the installation crew was done so that our network engineering team could then deploy the services that we could then allow the rest of the business to turn up their boxes. So that would be phase 2. Phase 2 was checking all of the protocol states, MLAG, LACP, BGP, all of the protocols, did they come up as we expect them so that when the phone team wants to deploy their phones, they would work. Or when the broadcast media people wanted to deploy their equipment and use the network, that it would work. Because we have all these many different teams and organizations throughout our company that are users of our network. So network ready for use for them meant they could start to deploy their equipment. So I'm only going to focus on phase 1, which is optics and cabling. And the way that this story begins is we as network engineers, we handed over these spreadsheets to the installation crew, and maybe you've seen spreadsheets like these, which basically says this box on this interface is supposed to have this optic, it's supposed to use this type of cable, and it's supposed to be plugged into this other other end. And we would give them this information, and they would go off and do their installation job. And what we had to do is we had to audit that. We wanted to make sure that the right transceivers were in the right interfaces and not the wrong interfaces. Because if somebody puts a 100 gig optic in the wrong interface and it's not being used, that's $10,000 we just lost in a sea of 20,000 interfaces. So finding all these mistakes are needles in a haystack, almost types of problems. And when it comes into the cabling, what we discovered is a lot of the cabling problems weren't just that they cabled something to the wrong port. Sometimes they flipped the polarity on the fiber optic so that the link didn't even come up. But as an installation crew, they didn't see that mistake. They just said, we plugged it in, we're done. And they couldn't see the lights because there's so many fibers running through these IDF systems that they just couldn't see the lights. So they thought they were doing their job, and then we were able to audit them. So what we wanted to be able to do was give them pinpoint auditing, meaning we could run a report and it would produce a spreadsheet that said, on this box, on this interface, there was a mistake and here's what you need to do to correct it. It gave them corrective action in a form that they could understand. So it was not in network ease, it was in installation ease. And from these reports, what we were able to do is then produce a dashboard that allowed us to get a really clean heads up of how far we were into being done. Now, what I'm showing you here is just a Google spreadsheet. There's nothing really fancy here. It was just pulling in data from CSV files into spreadsheets. But what I want to highlight here is every single mistake that you see here is a test case failure. So if I was running a test case, all of these are failures. But what we had to do is we had to prioritize those failures in terms of, was it an error, or was it a warning, or was it a to-do? And an error was something that was a mistake that was service affecting. For example, they cabled something to the wrong port. So that's a mistake. If they put the wrong optic, if they put an optic into a port that wasn't supposed to use an optic, that's just a warning. It's not going to harm the system. It's just, they just made a mistake. They need to fix it. And then to-do essentially indicates every test that failed that meant that they had more work to do. For example, maybe they needed to put an optic into a port or they needed to cable something. My cabling test failed, but it was simply because they just hadn't done the work yet. So what I'm going to show you is not only can you use PITest to run tests and get a pass-fail, but you can categorize or prioritize them into things that are meaningful to you. So why did we have to automate this? Again, it comes to scale. A lot of times people ask me, why should I automate something, and is it due to scale? I have 30 boxes. Do I need to automate my system? I don't have that big of a scale. Well, it really is, what is the facet or the measurement of that scale? I have 300 devices. We're not Google or Facebook with 10,000 devices. But if I calculated the number of tests that we would have to run, it was almost 23,000 tests. That's 300 devices, and those devices had 48 to 60 number of ports. But if somebody was manually and individually testing every facet, they would have to do 23,000 tests. Nobody's going to do that. They might run a few show commands and eyeball it, but nobody is going to do this. And what we found is because we were staggering our deployment, we couldn't just run one test and be done. It was sort of like we'd run a test on a room, and then the next week they'd get another room done. And then the next week, we found out we had to make a design change. We're like, oh no. We need 3 more switches in this room, so we'd have to change our design, add more switches, recompute all of our test cases, and then rerun everything again. So even though we didn't have a lot of boxes, the scale and complexity had to do with the number of tests and then the change in our environment, right? So that we had actually many changes throughout the installation. Like we discovered that one room didn't have enough power, and so we had to move boxes around. Or we discovered that the server guys made a mistake and we need 4 more switches to support all of the new interfaces that they had. So there was a little bit of design change and then refactoring of our test cases. Okay. So what I want to do is quickly show you what this looked like when we run the test, because I like to do like the cooking show. I like to show you the turkey before I tell you how we make the turkey. So what I'm going to do is I'm going to show you a few screenshots, and then I'm going to drop in and I'm going to actually run PITest so you can see what this looks like in kind of a real world environment. Can you guys see that okay? Yes. Okay. All right, so when you run PITest from the command line, you can get it to output in a way that shows you every single test case and gives you a brief result, just passes or fails. So you can quickly see these are all passing. You get a summarization at the bottom. You can see how many things that you're running. And if you get a failure case, it'll just say failed, and you can see the summarization at the bottom. Now, what I wanted to do was get more data. I wanted to understand, well, what was the nature of that failure? So a plugin that you can get with PITest allows you to get your reports in an HTML output. And you can then bring up a page, and then you can kind of point and click through that page. And here what I'm doing is I've opened up a little bit more detail on those failures. So it shows you, for example, that where an optic was expected, there wasn't one, right? And so that's a mismatch. In the vernacular of my test case, that was a mismatch. I had a certain expectation that there would be an optic of a certain type, and the actual was there was no optic. Now, that's a test case failure, but when I translated that to the facilities people, it was, that's a to-do. You need to install an optic in that place. So what I'm going to do now is I'm going to kind of drop in and show you what this looks like. And I'm going to take you through a few command line options with PITest so you can kind of see what's available with PITest. I'm also later going to show you how to install it and do all the things, but I just want to get to the good parts right away. All right, everybody see this okay? Yes. All right. So in the GitHub repo, there is an offline demo and there is an online demo. So the difference between the two is the offline demo is going to use output that I've captured from devices and saved to file. Because the World Series is going on right now, I am not going to touch the network. Okay. But if you also want to play with online devices, I actually have an online demo environment. So I'm going to show you both. I'm going to try to show you both today. But I'm going to demonstrate the offline demo. Now, what you see in this directory is a bunch of files that begin with the word test. By default, PITest will find every file that begins with test underscore automatically. And then inside those files, it will run every function that begins with test underscore. So that's what they would call their collection process. They're collecting all their tests. Now, I put these numerics, 0, 0, 0, 1, so that PITest would run those tests in that order. By default, it's just going to run them in alphabetical order, and that allowed me to force it in this way. Now, if I type in PITest, and I'm using a virtualized environment, so this is just installed on my laptop, in a virtual environment. Everybody knows what a virtual environment is? Everybody's okay. All right. All right. So if I just type in PITest, it's going to say, hey, man, something's wrong. There's a couple of arguments that are required. Now, PITest obviously doesn't know anything about NRFU. These are arguments that I added to PITest. So I will show you how that works, because what I want to be able to do is say, I want to run the PITest set of tests against a specific device. So this would be like the host name of your device. My device is called device 1. And I have a directory of test cases here, which I'll show you in a little bit later, but that's where my test cases are stored. So I'm going to say my test cases are in this directory called dev1, test cases. Now if I hit return, what it's going to do is it's going to run those test case files. You can see they're in order. These dots indicate things passed OK, everything works great. But that doesn't really show me each individual test case like you saw before. So if I do -v for verbose, what it's going to do is, I'm going to stretch this out a little bit so you can see it. It's going to show you every test case, and it's going to show you the name of the test case. And this is really important. You can see this is the module that it ran. This is the function in that module. So there's a function called test optic inventory. And then this is the test case name. Now this is really relevant because PITest allows you to do filtering. For example, if I only wanted to run my optic inventory, I could use a -K, and I could just say the word optic. And in this case, it's gonna pattern match on this entire string. So it found optic, for example. Or I might want to do spine, and it will show these are my spine leaf. So it has a built-in filtering mechanism. It's not super powerful, but it allows you to control exactly what kinds of tests you want to run. So far, so good? All right. So another thing that you can do is, I don't necessarily want to run the test. Maybe I just want to know what tests would run. Sometimes you hear that as dry run mode in some of the other tools. They have this option called collect only. And this will show you these are all the tests that I would run, but I'm not actually going to run them. OK? Now, what I'm going to do next is I'm going to cause a test to fail, so you can kind of see what that looks like. And in order to do that, I'm going to just simply change one of my test cases. So in my test cases directory, I have a cabling file here. And I'm going to go into this in a little bit more detail. But I'm going to just change this expected remote interface. Instead of it being 3, I'm going to just change it to 13. And if I run this again, not in dry run mode, what's going to happen is it blew up. It basically created this exception. And you're like, oh, it's all this nasty, terrible stuff that, like, what's going on with this? And it's trying to tell you, if I was a software engineer, it's trying to tell me where in my code there was a mistake, because as a developer, I'd want to know that. But I don't want to see all this detail. So what I'm going to do is I'm just going to say, take these tracebacks, which is this traceback, and make it short. So now it's going to give me, a short explanation of what failed. It said, well, I've got this expected data. It expected, interface 13, but the actual data was 3, right? Or if I want to turn that off completely, I could say no traceback, and you can see that there's just an F here for failed. And again, if I put the -V back, then I could see exactly which test case, here failed. Now, while this is going on, I could also turn on the HTML. So in this directory, there's a little script here, a shell script here called run demo. So you can just say run demo. And what you'll see here is, I have to say run demo dev1. And what you'll see here is it's saying, I've created an offline demo report in dev1 HTML. So it actually created an HTML report. And that's because I added these flags here. Make an HTML report, and make the HTML report self-contained, which means the HTML file that I produced, I could email it to somebody, and they could open it up, and it's all one file, so I don't have like CSS files and all this other crazy garbage. So if I wanted to open that file, this is just the HTML file, and I could see this, and I'll make this a little bit bigger. I can see that this is my error, and I could say I only want to look at errors, and you can see right away what the error was. Okay? All right, so I'm going to close that out. So what we've covered really is, what PITest is, some of the command line options. We've covered some of the ways you can get verbose details out, a couple of different ways to see the information, but more importantly, how you can filter out some of that information. Now, while I'm demonstrating the fact that this was a greenfield use case for us, everything that I'm showing you could be used for brownfield. The fact that we're using PITest to gather information off the network and check its state could be used for brownfield environments. So I don't want you to come away thinking this is just a greenfield type of use case. Before I go into the next section, does anybody have any questions on this part? OK, great. OK.
One question.
Yep.
So as a workflow, which as you said could be greenfield or could be brownfield, it could be I run this test in my data center, is it still ready to run? Maybe you call it instead of is it ready to run? You showed the idea of having the list of exceptions that you give to people, either data center robots that you program with Python or people that are going to go swap optics and stuff. Do you give them a link to the ability to rerun the test on their own? Or how do you envision the workflow of these sets of things need to be done, and how much autonomy do you give them to see, to sort of run the component test that failed next to the thing that you're asking, the action?
Yeah, excellent question. So, and you'll hear me say this a lot, your mileage may vary based on your, specifics of your use case. Our specific of our use case was we had third-party installation crews, so what we had to provide them were spreadsheets that the foreman would then go talk to the actual installation crew. But even before we would hand those over, the network engineers would look over this report and they would kind of clean it up a little bit. They would say, oh, you know what, the reason why you're seeing this failure in this report is because we didn't even deploy that switch yet and you thought we did. So we would actually do a little bit of grooming before we sent it out.
But the third party doesn't have access to the tools, so they can't.
That's right, yeah. So we would run the tool, we would produce the spreadsheets, we would groom it, and then we would hand over the spreadsheets. That said, if we wanted to make a more robust tool for the internal use of our own team and we wanted to use this long running, we would take a separate self-service type of portal approach. Okay. Yes? That is later on in the tutorial. So every little piece of nifty thing, I'm going to show you piece by piece, code by code. How many of you are doing testing, in some semblance of just testing in general, like automated testing in some way? Okay. All right. So afterwards, I'd love to talk to you and understand what kind of tools you use, because I'm a tools junkie. But I'm going to talk about a few concepts of testing. Why do we do testing, and what is its purpose? So for us, we wanted to determine whether the network was ready for use, as I've talked about. And the way that we would measure coverage, you'll hear the term test coverage, is in our world for networking, it was how many devices do we plan to deploy? So let's say we had 300 devices. It was the total number of devices under test that were available versus the total number of devices that would be. So if we only deployed 150 devices, we already knew that we were only 50% capable to do coverage. And then for every single device under test, it had its own unique set of test cases. So maybe a spine had 100 test cases, and a leaf had 30 test cases. So it was a function of, for every device under test, how many tests were specific to that device and how many passed versus failed. And that's how we knew if we were done. So if we were to take any given device that we were testing against, we had these 3 specific test functions, and then based on the design and the use of that device, we knew how many test cases that we were doing. So in this case, we were testing 30 optics. We were checking to make sure that 30 optics were placed correctly. We're making sure that 36 interfaces were in the up state or the down state correctly. And then we had 34 cable tests that we wanted to run. So this one device, this one theoretical device had 100 test cases. So what I'm showing you here is what does a test case look like? Now, what I'm showing you here is the data for a test case. Now, I have a file, and in this file, I have many test cases. And the way I've arranged this is I have a file per test function. So this case is the cabling, the test cabling. So I'm going to have one file. All it has are cabling tests in it. And in this particular file, it's for the same one device under test. And what you'll see in here are parameters for this test. This is saying, on this device, I want to check interface 49/1, and its role happens to be a spine leaf. And I expect to see on the other side switch 21 connected on Ethernet 3. So you're seeing the type of test that I want to run, cabling, the device that I'm running it on, the parameters to run through the test function, and then the expected results. Now, where this information comes from and how this file is generated, I'm going to talk about later on. But the organization of this file and the structure of this was entirely my own design. Like, if you want to do something different, do something different. If you want to use XML, use XML. But the takeaway here is it's structured data that I can process, right? And I'm showing both the parameters that I'm going to use as well as the expected state, because how else am I going to know whether or not the test passes? The actual data is the data that comes from the device, meaning this is the operational state. So when I talk about actual data, this is, if I were to go on to, in this case, an Arista box and do show LDP neighbors, this is the output that I can get off the CLI in JSON format or extract via eAPI. So this is the actual data. And so when we're talking about comparing a test case versus actual data, we're going to take information from the device, use the test case, run it through a function, right? And that function is going to give us a pass or it's going to give us a fail, right? And so that's how we put all this together. We have actual data, the test cases, a test function, and pass and fail. Now what you saw when I did the PITest function, when I ran PITest, is a test case fails when an exception is generated, right? In my case, this test function, the one that validates the cabling information, it generates an exception. I'll show you the code. It says, does my remote host match this value? And it doesn't. It generates a mismatch exception. I do that because PITest naturally traps that exception as a failure and reports on it. And that's what I want it to do. So I'll show you how that works a little bit later. Now, I get a lot of questions from people like, well, how should I design certain things? And so I wanted to take a minute just to step back from the technology and just talk about when you design a testing strategy. It's important to separate the what from the how. And really what I mean by separate what you want from how you get it, right? For example, the actual data. We know we need the actual data, but how do we get the actual data? Right? How do we get it from the device? And the test cases, how are these test cases created? I had 23,000 test cases. I did not create them manually. I did not artisanally handcraft JSON. That's not what I do. Where are they stored? And how does the test function itself get those test cases into PITest? And this element of how does this information get into PITest is the main focus of the coding lab. So it's kind of an interesting application of PITest. All right, obtaining the actual data. One approach is to go to the data at the time you're running your test function. For example, I'm using eAPI. I'm going directly to the device. I'm getting it in real time. I'm using the real-time information. That's what I do for the online demo. But for the offline demo, I've actually taken a snapshot of all that data, saved it to data files, and my PITest functions are reading these snapshot data files, which is a completely legitimate use case. I mean, you might snapshot data off a network and then run it through an offline audit. When I was at a vendor, when I was working as a vendor, we did this all the time with our customers. We'd say, run these commands, save them in output, send it to us, we'll analyze your data. This is just an automated process of doing that. Another approach is maybe you have a collector that's collecting all this information. Damien did a presentation earlier today about collecting data into a database and so forth. So maybe you have a collector where all this data is coming from. Or maybe your vendor sells you a product that's collecting all this data and you want to go to their controller. So that's an option. Another option, or another question that always comes up is do you normalize the data so you only have to write your test cases once? No, I don't do that. That's ridiculous. I don't believe in that for a lot of reasons, but that's a different pedestal for another day. But maybe normalizing information is important to you and that's what you want to do. That's a choice you make, but there's no requirement to do that. The test cases. Now, this is where I do have an opinion. When you're going to make test cases, write a piece of software that automates your test cases, that builds your test cases for you. For example, I had that spreadsheet that you saw on slide number 3. I could process that spreadsheet and generate all my test cases. And if you've never done Python automation programming and you're just getting started and you're like, what's the first thing I should learn how to do? Learn how to do that. Like, take a spreadsheet, dump it to a CSV, process the data, automate some test cases. Because really all you're doing is creating, JSON files. It's a very simple it's a not complex use case to start developing Python skills. So where would you get them? Like spreadsheet like that. I have an internal database that keeps all this information for me. Maybe you use Netbox, and Netbox is a source of truth for you. You could actually pull your network information off of Netbox and use it as a source of truth. There are a lot of different options. And then finally, when you write your test functions, and I'll show you one, when I'm writing the test function that tests the EOS cabling, for example, my test function is very specific to the output of EOS. and I have a different one if it was for Cisco, and that's okay, right? Don't try to over-engineer a solution to try to abstract all the things, because it's not necessary, and it's a lot easier to write specific pieces of code in order to focus in on the problem you're trying to solve. Now, if you want to add layers of abstraction, that's okay too, but don't feel like you always have to do that. Okay, so just a quick recap. Test coverage is a collection of testing functions, and then how many functions you run over every device. It's okay to write tightly coupled test cases and test functions. I generally would suggest when you write the test cases, keep the same definition of the test cases, although the data that you put in there might be vendor specific. For example, the interface names may be Juniper or EOS or Cisco specific, but the structure of that test case, the fact that you had params and expected, keep that consistent. Okay. Any questions before I go into the next segment? All right, we're getting into the codey parts. Okay, intro to PITest. So my goal here is to give you a brief tutorial about some of the ways that you write Python for PITest. I could spend 2 hours just giving an introduction and covering all of this material. I have some links at the end where you can watch some really great videos on really getting to know PITest, but I'm going to just try to touch on the things that we're going to be using today. We'll cover test functions. We're going to talk about fixtures. We're going to talk about parameterizing tests, a little bit of running these filters against the tests, and creating the HTML output. All right, last slide before we jump into code. To install PITest into a virtualized environment, you only have to do pip install PITest. And there are over 700 plugins that you can use with PITest. I happen to be using the HTML version, or the HTML plugin. So there's a PITest HTML. But there's this great web page you can go to, and they've got loads and loads of stuff. All right. Let's do some good, fun stuff. All right, everybody who doesn't want to see Python coding, and now would be a good time to go, because the rest of this is we're going to be coding. All right. All right. All right, let me clean all this up. All right, so let's go in through a little bit. The first thing, we already covered the fact about, test functions begin with the word test, or test files or modules begin with test. There's also a special file called conftest.py. Now, you can think of this file as an automatically imported module by PITest. So anything you put in here is shared across all of your files. This is where you're going to put common functions or fixtures. So if you see this, I'll show you what's in here. It's not required, but that's just where you put I think about it like globals, right? So what I'm going to do is I'm going to create like a brand new directory, just brand new. We'll just start from nothing. I'll just make a directory called Today Demo. All right. Nothing in here. Okay, so I have Today Demo. I'm going to create my first file. I'll call it, test this. And all I have to do is make a function. I'll make this bigger. All I have to do is make a function. It just has to begin with the word test. I can call it this. And I can return any value. This doesn't do anything, obviously. But if I just do PITest, it's going to run test this. You'll see a little dot here. Worked. Right, if I do -v, it says that it passed. Not very exciting. You'll notice that even though I return false here, it still passed, because this test didn't cause an exception. Right? If I want to cause an exception, like I could say assert, if I can type, assert true is equal to false. Now, obviously true is not equal to false. So if I run that, you can see that it tells me, sure enough, true is not equal to false. It gives me an assertion error. It tells me this failed. And this is how I raised an assertion. Okay? Now, what you can do is you can put some helpful message here. You could say, duh, true is not false. And if I ran this again, you can see that you get a little bit more, information here. Okay? And if I gave it traceback is equal to no, remember this will just tell me that it's failed. And if I do short here, it'll just give me a little bit. Okay? Just a little bit. Just by way of comparison, I'm going to flip back over to my offline demo. And I'm going to run this, this thing right here, the PITest. I'm going to let my EOS function blow up. Right? I'm going to run PITest NRFU device dev1 NRFU device or test case dir dev1 test cases. I'm only going to test the cabling. Nope, test case the cabling. NRFU test case dir. Yeah. Thank you. It's live. All right. Okay. So what you're going to see here is it's showing me the code where this blew up, right? And if I scroll up, you'll see that there's a function called test cabling, right? And it even tells me where this blew up at. So if I was a software engineer and my code had an error in it, this is really, really helpful, right? It tells me exactly the line in my code where it's raising an error, in this piece of code. Here I can see the exception type that it's raising. But for us, when I do this test right in this file, it's not really interesting. It's like it's just happening in that file, right? Okay. There's another way you can generate an error. If you import PITest, rather than doing an assertion, you can just say PITest fail, this test case failed. So you can see that it gives you a different type of error, it just failed. So if you're writing your test case logic, maybe you write your test functions to generate exceptions, which PITest will catch normally, and that's the way it's supposed to work. Or maybe you want to use PITest fail as a direct function. There's no right or wrong answer. These are just choices you can make. Okay? The next thing that I want to show you is something called a fixture. Now, when PITest runs functions, like if I made another function in here called test that, you can see the same function it's running, it's testing these two functions. When I was creating test cases that was running the same function again and again and again, but had different test cases, what I was doing is I was parameterizing that test case, right, to pass in a different set of options over and over again. That's called parameterization. And there's two ways that you can do this. I'm going to show you the way that you're going to read on the internet, and then I'm going to show you the way that I learned how to do it for this particular use case, which is a dynamic way. Okay. So a fixture is a function that essentially returns data. So let's call it these items. This is a function, and I want to return a list called this, that, bananas. Right? This is a function. Now, what I want to be able to do is I want to pass these items to this test function. Okay? Seems a little weird, I know, just hang with me for a second here. And what I want to be able to do is I want to look at these values, and let's say my test was, does it begin with the letter T? Right? So I would say, for item in these items, assert that item starts with the letter T. Okay? Now if I try to do this, this is going to be an error. It's going to tell me it's an error. It's going to tell you, hey, this is not a fixture. So what you do is you say, I want to declare this as a fixture. This is a fixture. And a fixture can have a scope. And what a scope means is it means how often do I rerun this function. So if I say scope is equal to module, it means that this function is only going to be invoked once for this module, right? If it's by a function, it means that this is going to be returned every time this function is called. There's another one called session, which is a lot like module, except session means just globally once for every single file. So now when I run this, what you'll see is I have this one test case, and it failed, and it told me, bananas doesn't start with T. So far, so good, right? But this doesn't give me a test case per value, right? That's what I want. So what I want to do is I want to parameterize these items. So rather than doing it as a fixture this way, I'll comment that out. What we want to do is we want to use something called parameterize. And what we're saying is we want to parameterize these items with the value this, that, and bananas. Okay? So what this is saying is it's going to take this. This is the variable that we're going to parameterize. It has to match this word here. And it's going to invoke this function 3 times. So now it says, this, that, these all failed because this is no longer a list, right? This is now an item, right? So because this is being iterated, the value is first the string, and then it's that, and then it's bananas. And so I was iterating over a string. That's the wrong thing. So really, what I would do is I would change this to be item, and this is item. Now it's going to iterate over each. And I have to get it, you have to match the words. And now you can see like this passed, that passed, but bananas failed. Okay? So the reason why I'm presenting this material like this about parameterization is because the main function of everything that I'm about to show you next has to do with parameterizing the test cases based on the device. Because one device is going to have a different collection of test cases. Now, what you're seeing me do here is I'm hard-coding these values. Now, if you have a database full of test cases, you can't hard-code them. You can't hard-code them based on a device. So what you really have to do is you have to dynamically parameterize these tests. And this was really the aha thing that I had to figure out how to do. And this material has never been presented. I've never seen this material presented online. So what I'm about to show you today, I've never seen it presented, even in like programming workshops. I showed this material to a PITest expert, like who reviewed my slides. And he's like, I haven't seen this done before. This is really cutting edge stuff. So good luck with that. So you guys get to see it first. All right. Any questions about this level of introduction about PITest? Okay. I'm going to get back to the slides. I'm doing okay on time, actually. I'm doing great on time. So am I going too fast? All right, good. All right. So now we're going to go through every single piece of code that I had to write and use with PITest in order to make it work for this particular use case. I'm going to show you about 4 or 5 advanced techniques of PITest. If you buy the PITest book, which I highly recommend, and it is excellent, you will not see any of this material. Yeah. Okay. But here's what we're going to do. I'm going to show you how to create your own options, because you might want to have a whole different set of options than I have. You can also set up config files, like an INI type of file, and pass that into PITest. It does support file-based configuration. I'm not showing that, but just to let you know that it does support that. The second thing that I'm going to show you is we want to verify that the device is online and reachable before we run tests. For example, if I've got 100 test cases, I don't want to try to run 100 tests against a device that isn't even online and get 100 failures. I want to know that the device was unreachable because that's a different type of failure to me. Now, once I have validated that the device is online and reachable, there are a few things that I want to do. The first is, after I make a device connection, I'm going to have like a variable called device, which allows me to communicate to the device. How many of you guys have done things like Napalm or PyEZ or these types of libraries where you have a device instance? Okay, so this is what I mean. You have a mechanism by which to communicate information back and forth to the device. So how do we pass that to the device? The answer is it's going to be a fixture, and I'll show you how we would build that. And then I'm going to spend a lot of time talking about how we dynamically load the test cases for the device and parameterize our test cases. And then I'm going to talk about bulk data type of device commands. These are commands that maybe give you a lot of data. Like the example I'm going to show you, show inventory, where you use that same data again and again and again through multiple iterations of a command. So you're not doing show inventory 100 times. Okay? All right. Now I'm going to take a little while to explain this slide. So I'm going to explain my testing strategy and how I'm doing this with you guys today. I have written a single test file or module per test function. So I didn't write one Python file that had test optics, test cabling, test interface. I didn't do that. Like each specific test function was its own Python module. And there was a reason for that, which I'll go into. But every single file has a basic formula that you're going to see repeated. There's a section of code that says how to load the test cases for that specific function. There's a particular way that I'm going to get the information from the device. If we were doing an online example, and I'll show you the code, it would make a call out to PyEAPI to talk to the device. We're going to do pulling the data from a snapshot file. And then there is a PITest function that's going to get invoked. And what it's really doing is calling another function. So I've built a library that is currently called NRFU PITest EOS. And what this library is just the test function validators. It actually has nothing to do with PITest. I'm going to change the name. All it's looking at is the actual data against the test case. And the reason why I did that is because I wanted to potentially use that same library with a different testing framework. Maybe I wanted to use Robot. Maybe I wanted to use Ansible. Maybe I wanted to use something else, right? Maybe you have your own testing framework. But writing the validator, is the same no matter what framework. So, so there's a library that you're going to see in the GitHub repo, and it looks, and I'm going to show it to you now because I want to show you what a test function looks like. In the repo, you'll see it's called right here, and you'll see that there's a bunch of functions in here. I'll go through these in a little bit of detail, but every single PyTest function follows the same basic formula. Okay, and every single device has a directory of test cases. So in my offline demo, you'll see that I have a directory called dev1 test cases. And here are my cabling, right? You can see that this is really just a JSON file. It's a list. And you can, what's that? Oh, that's weird. Oh, thank you. Let me get over to that, get out of that. Thank you. So in the repo, you'll see that in the offline demo, there's a directory of test cases, right? And you can see like there's one for cabling, there's one for interface status, there's one for optic inventory. So I've segregated every single test case by function. Now, in my production environment, I have a database, and I read from a database, and it's all very nice and magical, but that doesn't demo well, in this kind of environment. So I wanted to make everything easy for you guys to play with. So if you wanted to download this GitHub repo and tweak it and play with it, I like to call that, cake decorating. I give you something that works. You can kind of ice the cake the way you want it, and you can play around with it. Didn't want to put the database in the mix of things because that would overly complicate it. But what you're seeing here is really just a dump of my database into files so that we could use it for today's presentation. So every single test case, essentially is a dictionary, which says, its function, the device, the parameters, and so forth. So this one, I'm just going to fix back so it's not broken. And that's how every single file is laid out. For the offline, for this offline demonstration, what you'll also see is this directory where I have all the output for the show commands. So here's the output, again, for show LLDP neighbor. I just captured some information, and I kind of cleaned it up for our demo. Same thing for show inventory. Here's some information from the inventory section, that we're going to use for our demo. Now, the next thing I want to show you is a check. So this is a function that is in this library. And in this library, it's called test cabling. Now, if I had to do this all over, I would probably not call this test cabling because in the PITest module, it's also called test cabling, and it's a little confusing. So maybe I would call this verify cabling, because really what it's doing is it's taking the actual data from the device, and it's taking the test case data, and all it's really doing is comparing the information in those two dictionaries. So what does that logic look like? The first thing that it does is it says in the actual, in the actual data, I have this data structure called LLDP neighbors, and in my test case parameters, I have an interface. So what I end up doing is I first check to make sure that that interface shows up in the LLDP output, because maybe it's there and maybe it's not. And if it's not there, then what I generate is a missing error. I say that this information is missing. I can't perform my test case because the thing that I'm trying to measure is missing. So I've created a very specific exception type called missing error, which I'll show you in a minute. But rather than using a generic type of error from Python like value error or runtime error, you can create your own exception classes. And it's this process by which I could then use to prioritize, is it an error, is it a warning, et cetera. So you have a lot of capability to customize the type of exception and how you interpret that exception through PyTest. So I do this a lot because sometimes in the networking, when we pull out data, there's things that we want to measure, things that are ephemeral pieces of information like an ARP entry or an LLDP entry. And if it's not there, you want to know that it's not there versus it's there and you're measuring it and it's wrong. So that's the first thing I do is make sure that it's there. And then I look and I see, does the interface or does the remote device match? And so here I'm kind of looking at the actual data compared to the expected data. And I'm lowering the string so that I don't have to worry about string compares for capitalization or whatnot. So I'm saying, does the remote system match? Is it switch 5 when I think it's switch 5? And I'm basically generating a list of types of errors. So because there could be more than one error. Like maybe it's the wrong device and it's the wrong interface, or it could be just the wrong interface on the correct device, et cetera, et cetera. So I'm trying to check all the things, and then I just kind of put them into a list. And if I have any errors at all, what I'm then generate is I generate a mismatch error. And you can see that this type of error actually supports an actual, an expected, and an actual. So this is my exception. And the reason why I do this is because I want to be able to capture the data in my exception and pull that data back out without having to string parse anything. I just want the data so that I can manipulate and use that data, and I can create valuable types of reports based on that data. And you can see that every type of exception that I create, I do implement the string method. And this is what shows up by PyTest. This is when they interpret that exception, it translates that exception into a string, so you get that output on the either the CLI or what you saw in the HTML report. So you have control over what you want to report and how you want to see it. And that's how you do this. This NRFU exception is really just implementing or subclassing runtime error. It doesn't have to be runtime error, it just needs to be an exception class. Again, all this code is available for you guys to look at. All right. So that's what a testing function looks like. It's really just comparing those two pieces of data and generating an exception based on the logic that you have. All right? I'm going to go back to the slide deck now. So the first thing that we want to do is we want to be able to customize the command line arguments to PITest. PITest is one of the most extensible framework pieces of software I've ever worked with in Python. It's probably my #1 package to use in Python land of all time. It is quite amazing piece of software. I can't say enough nice things about this stuff. When I teach automation programming to networking people, this is one of the first things I try to teach them is testing. Like, I try to teach testing first. The parameters that I wanted to create was, this is the device that I want to connect to. This is usually the host name of the device. This is how I'm going to make a connection to it. And then the directory where the test cases are located. Okay? Now, the way in which you hook into the PITest framework is through a series of very specific functions, and they're called hooks. So if you go onto the PITest documentation site, there's a very specific section called hooks. And they're not, they're documented like you would imagine a software programmer would document them, but they don't really explain how to really use them. You're left hunting around. So the purpose of this tutorial is to show you how to use these things. All right. So I'm going to actually show you the code. I'm going to play with the code so you can kind of see how we do this. There is a hook called pytest add option. And you put that in the conf.test.py, that top level file. And this gets called before everything is run. And it works a lot like parse args, if you're familiar with Python general args processing. And in it, you can tell it which arguments that you want. You can tell it if it's required or not. And you can do it a little bit of help. So I'm going to go back into the offline demo. And if I do pytest -- help, and I look for NRFU, you're going to see that there are these custom options. And you can see that I have NRFU device. I have one called NRFU test case directory, which you've seen. And then I also have one called SSH config. I don't know if anybody uses SSH config files a lot. I use them a lot because a lot of times my devices are not in a DNS or a hostname, and I use an SSH config file to deal with IP addresses and usernames and passwords and so forth. OK. So if we look at, in the library, in NRFU PITest EOS, if you look in that config test.py file, you'll see this pytest add option, right, where this has got defined. So if you import this library, and you import this function, you get it automatically. So in the offline demo, for example, if we opened up that pytest.conf file, what you can see is that I imported, from this library, I just imported that hook, which means I get it by default. OK? Now, if I wanted to override that and do anything that I wanted, like say I wanted to kind of mess with this, right? Now, I'm not going to add any special items. So now if I do this and I go to custom, there's not going to be any NRFU in here. There's no NRFU in here because I kind of there's nothing there. So if I wanted to create one, I could say, parser dot add option. You can see there's an add option function. You give it the command that you want. So add option, and I can say, host name, help equals, this is host name. Now, I didn't say required is true, right? So I can do grep hostname. You can see now there's hostname. And if I wanted to make it required, this means that it won't run unless I provide the value. You saw that before, how the program wouldn't run unless I provided some value. So all that is doing is it's setting up a data structure inside of PITest. It's not actually doing anything with it. It's just setting it up so that I can use that information later. It's setting up this object called config. So in PITest, there's a config object that allows us to store that information and make use of it later. Okay? All right. So the next thing that we want to do is now that we've provided the host name or the device name, we want to reach out and touch it. We want to make sure that it's reachable, that our credentials are correct, that things are OK. And if it isn't OK, we want PITest to exit out immediately. Okay? I'm going to show you both offline and online. I can't do the online test because, again, World Series. But I'll show you the offline version of this, and we'll do a little cake decorating as we go along. All right. So for the online, the way we do this is there's another hook function called session start. And it is passed a session object. And the session object has the config object. So where we just set our NRFU device name and our NRFU test case, this is what stores that. Now, I'm doing something a little fancy here, but really what it amounts to is I am creating a private piece of data. This is why you see the underscore. And because I have access to this config object throughout all of my test functions, I'm going to want to refer back to this information again and again and again. So I'm going to store this information for my config. So here's my NRFU. And what I'm doing is I'm storing my test case directory so that I have it available to me as a Python path object so I can read from it. So here I'm getting the device name from my option, so you can see how I'm getting it. I'm getting the SSH config to see if it was passed. And then this is PyEAPI device object, and it's going to pull in that device object and create it based on the device name and some of my SSH config. And then what I do is I probe to see, is my device reachable? If my device is not reachable, meaning the IP address is not online, then I'm going to call this function PITest exit. And this is what causes PITest to exit the way you saw, where it'll stop immediately. But to me, that's not good enough. Just to make sure that I can test it, IP reachable is one thing, but I want to make sure that my credentials were OK as well. So I try to run one command. I do like show version just to make sure that it works. Or I happen to be passing environment variables called EOS user and EOS password. Maybe I forgot to set them, which happens a lot. So, right, and so I'll try to execute this command, and if it generates a connection error, I say, hey, maybe you forgot to do this, and I exit, or if it's not a connection error, it's some other type of error that I don't know, it'll just tell me, hey, I don't know how to get to this device. But here's the interesting thing. I then, once I have this device object, I then actually hold on to it. I store it. Now, this is not like, this is not normally what you should do, but it works, so, it's open source software. So what I end up doing is because I'm already connected to this device and I know that it's good, I want to hold on to it because I want to get to it later. Right? So I actually store it, I attach it to my little private piece of area and I call it .device. Now for the offline, I don't have an actual device that I'm talking to. What I have is a directory full of the actual show data. Right? So let's take a look at what that looks like. That looks somewhat different. So for my offline demo, again, I'll go into this PyTest or the conftest.py. I have PyTest session start. And you'll notice that, again, I set up this config NRFU private dictionary. I just set up a dictionary, and I say My show outputs directory is the directory that I happen to be in, the device name, and then dash show outputs. This is, again, it's a demo. But you can see I've got device name dash show outputs up here, and this is where all this data is. But you don't see me actually doing a test. Like, well, what happens if I provided a device name that didn't exist, and I didn't have that data, and then it tried to use it? Well, this is what happens if I try to do that. If I say dev2, it's going to try to run stuff, and I get all these errors. Like, I get all these errors because that file doesn't exist, right? Let me do it this way. PITest, NRFU device, dev2, NRFU test case directory, test case, dev1 test cases. You see, it basically said every single test case failed, right? This is what I don't want to do. All right, let me just do that again with -stb equals no. So essentially this was, I can't get my data. This is what this is really telling me. I couldn't get my data because dev2 doesn't exist. But I didn't put that check in my session start. So what would I do? So let's do a little cake decorating. I'm going to go in here, and I've got this show outputs directory, right? So maybe I want to make sure that that works, right? So I want to say session config NRFU show outputs dir exists. Or I could say is directory. If not directory, then PyTest exit no directory for this device. Right? And of course, you can have coding errors all the time. We'll fix that. And it says no directory for this device. So this is what I mean by cake decorating. I'm giving you something that works in the sample directory. You can kind of play around and tweak with it. Okay? All right, so that covers how do we verify that a device is online. Now, you might have multiple things that you're connecting to. Maybe you're trying to connect to your database. Maybe you're trying to connect to a controller. Maybe you're trying to connect to 3 or 4 different things in order to automate your processes. Maybe you're trying to connect to Ansible Tower because you want to run some jobs with Ansible Tower. This is where you would hook in, ensure that you have reachability to all the systems that you want to test or communicate with, and do that once before you start launching into all your test cases. So this is a slide that talks about that, which we covered. And now that we have this device object, how do we get that device into our test case? Because we want to use that object in order to communicate with the device. For example, what I'm showing here is, for this cabling test, I want to run the command show LDP neighbors for the given interface so that I have that actual data. But I need that device instance. The way that we achieve that is through that fixture, right? Remember, we defined a fixture, and we have this fixture called device. So in any file, anywhere in my test case or my testing infrastructure, I can use that fixture called device because it was located in that global conf test file. So no matter where it is, no matter what function, you can use it. And that's why it's designated as a scope equals session. Session means that this function is going to be run once and only once. No matter how many modules use it, no matter how many function calls happen, it's only going to be invoked once. And here, what I'm showing is I'm just creating a device instance, and I'm returning that device instance. Now, that's one way of doing it, but the way I did it, because I did it a little bit more fancy, was in the online version. Remember, in the online version, we actually kept it around. We kept this device around. And so this fixture is really simple. It just says, in this scope session, in this device, I have another fixture. Again, remember, this is kind of advanced, right? I have another fixture called request. Request is a standard PITest fixture object, and it allows you to gain access to all sorts of really good things that PITest is holding on to, one of which is the config object. So if you ever want to get information about the config in any one of your tests, no matter where it is, all you have to do is include the request fixture in your test function, and then from that you can get information out. So what I'm doing is I'm using that to gain access to the config structure, to gain access to my private NRFU config, and it just returns the device instance that was actually first created when we started our session, right? Now, this is a little bit fancy. You know, you could just recreate the device, you know, make a second connection. There's nothing wrong with that, but this is the way I did it. Okay? If you look at the offline demo version of the same function, what it's really doing is it's creating this device instance. It's never trying to connect to it, right? I want to maintain the same device instance structure, but I just tack on this directory called show outputs dir, right? Because this is where, you know, this is where I stored it. You'll see where I use this in the test functions in a minute. So again, the whole purpose of this fixture is to return the device object that my function is going to use. Again, it's a session level fixture. All right. When I first started, just as an aside, when I first started using PITest, my brain exploded with all this fixture stuff. It was like really, really weird. It's like, why are there fixtures? Why are there different scopes for these fixtures? How do you use them together? There are again 45-minute video presentations just on the use of fixtures. So my goal here again is to expose you to these terms, get you interested in it, let you guys, you know, dig in as much as you want and in detail as much as you want. So the next part is the real hard stuff. Okay. So now that we've dynamically set the host, you know, is it dev1, is it dev2? We pass that as a parameter. What we want to be able to do is pull in the test functions and the test cases that are specific to that device. Now here I'm saying my test files are located in this directory. So switch21.build1 is a directory, and it contains files for all my test cases. In my production environment, that actually, I might not have that. It might just be, I'm just pulling from a database. But I'm telling PITest where to get this test case data. Because, and I want to reemphasize this, because what I want to do is I want an individual test case run for every single test case. I don't want there to be just one function that is 20 test cases, and if one failed, the whole thing fails. I want individual context-sensitive information so that I can pinpoint what needs to get fixed. Okay, how you do this. So what we're going to do is we're going to introduce a new another fixture. This fixture is going to be the test case. This test case is going to be one and only one dictionary of information that I showed you. If I got a file of 100 test cases, this fixture is going to contain only one dictionary, the one that we're iterating through. And we're going to use that information so that we can then call the actual PyEOS cabling test function. So you can see, like, I'm using that word test function or test cabling twice, and it looks a little confusing. I'll clean this up in the next pass of this, where the NRFU would say NRFU verify cabling. Because what's happening in the NRFU.testCabling function, that's where it's comparing the actual versus the expected values. But the question is how do we parameterize that test cases file, or that test cases fixture? Now, the way we do this is there's another hook function, and it's called generate tests. And its sole purpose, well, its primary purpose is to dynamically parameterize fixtures. Okay? So what's happening is that this function called PyTest generate tests, it exists in every single module. So in test cabling, there's this function. In test optics, there's this function. Every file gets its own copy of this function. And PITest will call this when it's trying to figure out what tests it wants to run. And what we're doing here is we're saying, OK, I know the test case directory because that was passed to me from my options. And what I want to do is I want to go find the file, test cases-cabling, in this case, .json, and I want to load that file, and the contents of that file are going to be what is going to parameterize the fixture called test case. So there's a lot of blocking and tackling in here. We'll go through it a little bit specifically. This file, again, we're going to load it. We're going to get the JSON payload out. That's going to be a list of dictionaries. That list of dictionaries is going to set the fixture called test case. And I'm going to get into the thing called IDs in just a second, so we'll come back to that. But again, what's really, really important is that the string value here, test case, matches what you have in your test function. Just like we did the pytest.mark.parameterize, remember how those two names had to line up specifically? Same exact rule, right? This string identifies the fixture and the function. All right, so let me kind of flip over to some code so you can kind of see how that works. OK. So here I have my test function called test cabling. And these are all fixtures. Any parameters, this is important to know, any parameters that you pass to a PyTest function are fixtures, right? Because PyTest is invoking this function. So here's my test case. And you can see in this particular file, I've got this function, generate tests. Generate tests is past this thing called a metafunc. I don't know why they called it this. This is just sort of like abstract magic. You know, they just gave it a name. But in this metafunc, you can gain access to the config object for which you had your test cases directory. Remember, we got that out of our test cases. And because I created this as a Python path object, what I'm doing is I'm taking that directory and I'm saying, find me the file, test cases JSON, and that's going to be my test cases file. And I'm going to load that file into the test cases fixture. So there's this function here called Parameterize. You can only call this once. You can only call this function once. So everything that you want to stick into this fixture has to be done once and only once. And then, if there's 100 of those, this test case here gets called, this function gets called 100 times, and this test case changes for each of those values. So this is really kind of tricky here. The reason why this function exists in this file and not in the global conf.test.py file is because if it was in the global file, then you would have to determine which function you were trying to load. Am I trying to load the cabling? Am I trying to load the optics? Am I trying to load the interfaces? Because this is essentially hard coding, hey, I want to load this file, right? I originally had this function in the conf.test.py global file. And then I had this big if-then-else. If it's this, then load this file. Else this, load this file. Else, 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 else. And it got really unwieldy. And what I learned through experimentation is that if I put this function directly in the test file, then I never had to worry about what the fixture name was. I could always call it test case because it only applied to the values in this file. OK? I'm going to say this again. If you put this function in the global, then you'd have to change your fixture name to uniquely identify that function. Instead of calling it test case, maybe you'd call it test case cabling. Or if it was optic, you'd call it test case optic. Because if it was in the global file, you'd have to know which fixture you were parameterizing. And that, again, became unwieldy. So that's why I basically isolated or tightly coupled that function in that file. And it's also why every test function has its own file. So it keeps everything nice and clean and modular. All right. I know this is a lot to digest, so we're right on time though, so we'll have plenty of time for questions. All right. The next really cool part is remember how I was showing you you could filter based on the test case name. So you will want to control your test case name because if you want to filter by it, you're going to want to control what that name is. And the way that that works is by also providing a function to the parameterize call that says for every dictionary of data, for every item in this list, call this function, and that function returns the test case name. So really what this function is doing is it's looking at the data, my test case data, and it's building the test case name based on the test case data. And that's how I get, this interface on this device is supposed to be connected to this interface on this device. You can see that the test case says this parameter interface, meaning the interface that I'm testing against, should be connected to, through this role, because I have role in my test case, to this remote host and interface. But you can arbitrarily control that, whatever you want the test case to be. Now I'm showing this here in the parameterize hook function. This is also true if you were using @pytest.mark.parameterize. So if you're not using dynamic, this dynamic mechanism, you can also use it in the static mechanism. So controlling your test case names is really, really important for filtering, to taking advantage of that capability. Because ultimately, this is what we want to get to. Again, we want to have individual tests run for each of those test cases, and we want to control their names so we get pinpoint information of what we wanted. All right. This is the last use case. This is dealing with bulk data. So what you saw before was I had a test function that said, OK, you've given me the interface. I'm going to call show LDP neighbor on that interface. I'm going to get just the data for that interface. That's my actual data. I've got my test case. I compare the data. I report. But many times on operating systems, you have to do one call, or maybe you have to do a couple calls that have data that you're going to use again and again and again. So on my Arista equipment, for example, if I want to know where the information about the transceivers, there's not like a show interface transceiver that gives me back my transceiver data. I have to do show inventory. And I don't want to call show inventory multiple times, once for each interface, because it's the same, it's not going to change. So I just want to do it once. That's what I mean by a bulk data. And the way that we do this, we already learned the construct here is we're going to create a fixture that's module level. So again, in this case, we're going to create a fixture. We can put this fixture in the test function itself, in the test module, the module itself. We don't have to put all the fixtures in conf.testpy. You can put fixtures anywhere you want. And here you can see that it's calling show inventory. And that's going to get called once and only once for the module, right? If you do not provide scope, if you don't specifically say scope is equal to module or scope is equal to session, it defaults to function. So if I didn't say this fixture was a module, every time I ran that test, it would call show inventory. So if I had 30 interfaces, it would call show inventory 30 times, and we don't want to do that. So that's how we get that data in there as bulk. And then again, when you look at the verification function itself, it's going to look through the data structure to find what you need. Just to highlight that, I'll go into the actual testing validation function here, which is the optic. And you can see that this test optic inventory looks at the actual data. It looks for the transceiver slots in this case, and does the same pattern. I'm looking for the interface. Make sure the interface exists, in my inventory, and if it doesn't, say interface not found, and then it goes through and then checks the expected model. Okay. In every one of these files, what you'll see at the top is what the test case structure looks like. and then you'll see what the inventory information looks like. So I tried to document these so you'll have a sense of what information is being captured and compared. Okay. All right. Thanks for hanging in there for an hour and a half. I'm just going to recap, and then I'll take some questions. You know, I've been working on this problem of operational validation for quite some time. In the networking automation space, for a very long time, everybody's been talking about config automation, config automation, config automation. I personally believe that validating operational state is a much harder problem because you have to understand what the expected values are. You have to understand or know the expected state, and how you keep track of that is really based on the design of your network, which is a distributed systems problem. It's very complicated. So as network engineers, you deal with this complication all the time, and you're manually doing these tests in your brain. You know, based on some Visio diagram or whatever it is, you know what you expect to see, and you run these commands, and you're doing this manually. But automating that process, or providing tools to help you automate that process so that you have the Iron Man suit of automated testing, is not a subject that we hear a lot about right now. So I'm hoping we hear more and more about how people are automating their operational state testing you know, in the future, because I think this is really one of the harder problems to really contemplate in network automation. PITest is a good framework for doing this. There are many. I like using PITest because it gives me a very native Python programming interface. There are other testing frameworks out there like Robot, which have their own kind of programming language or mechanisms, and they offer different capabilities. So there's not a right or a wrong. It's just what you're comfortable using and what you want to take advantage of. I know a lot of vendors are actually producing Robot libraries so that you can use them without having to roll your own. So there's a lot of interest in Robot. I haven't seen a lot of stuff in PITest, to be honest. Again, this is my preference as a Python programmer. It has a huge following. PITest is one of the largest test frameworks out there for Python programming in general. So it's a very well-established, very large community. There's tons of plugins. There's lots of presentations online. Again, I'm using it in the world of networking. I adapt these tools that we find out there for the problems that we have in networking, because in networking, we really don't have any cool tools of our own. We've been trapped in this world of vendors will sell you products that don't work very well, and then they say that they'll fix them, but they don't really mean it because you bought their hardware, and then they don't really care about your software. So I think things might be getting better, but honestly, we don't have a lot of really good tools in the networking space. So I've been looking at the server world and the DevOps world. I was very early on in applying Ansible to networking and some of the other tools. So I always look to see what the server guys in the cloud, the server people and the cloud people are doing, and try to adapt it. Everything I've shown you, the techniques, they can be adapted for brownfield or greenfield or both. To me, greenfield is just brownfield -1. The moment you put something out, it's brownfield. Boom, it's done, right? The story that I was telling you about when we were deploying our new equipment into our building, the second week it was brownfield because we had a change to our design, and so it was brownfield. So to me, there's no such thing as greenfield and brownfield in the application of these ideas. You can use them for any use case. You still have a lot of work to do. There's not a free lunch here. You still have to write your test functions. You have to still come up with your strategies that I talked about. Some people have approached me about taking this NRFU stuff and making it a little bit cleaner so that there's a community of test functions and libraries and a little bit of more things that people could share. If there's interest in that, I think that'd be great. But I think there's an opportunity here for more operational automation tooling and testing, because we don't have a lot of it. These are the reference links. The first one is, again, the link to my GitHub repo where you'll find all of the code, all the docs, online and offline examples. I can't tell you it's perfect. If you do try it out and you find an issue, problem, open an issue in GitHub, and I'll try to fix it. A lot of these other links and references are to the PITest docs themselves. So I tried to highlight the ones that we've covered today. There is one that is the talks. So the fourth bullet down, that page itself has a whole list of talks and videos and presentations that cover a wide range of beginner to intermediate level stuff. So if you heard me say the word fixture a dozen times and you're still like, what's a fixture? Because that happens. There's a lot of really good stuff out there. The book, the one with the rocket ship, I personally own. It's excellent. I think it's really, really great. The gentleman who wrote it, Brian Akin, if that's how you pronounce his name, he actually reviewed my slides, which, thank you, Brian. And he's like, this is really cool stuff, so please talk about it. The other book, I don't have myself, but it comes highly recommended. These are both very not expensive, and if you're very serious about getting involved in using PITest, I recommend them highly. This pythontesting.net website is all you could eat, man. There's just like, podcasts and video presentations and articles just all about Python testing, et cetera, et cetera. Great resources. And then if you want to follow them on Twitter, pytest.org is their Twitter handle. So with that, I've got 20 minutes to answer questions or show any code or do anything you want to see that's in more detail. Anybody can ask questions, even Damien.
Hey, Jeremy.
Hey.
Thanks for presentation. Very simple question, actually. You mentioned you had 300 devices, but every time you were it was like for one device. It was actually mandatory options for one device. How do you manage the tests on the 300 devices at once?
Yeah, excellent question. So what I glossed over was when I was running PyTest, I did it on a per device basis, right? So if I have 300 devices, I would have to run 300 PyTest calls, which I did. Like I had a bash script and I just iterated over them. And so it wasn't very efficient, but it was cheap and easy for me to dump my database of of devices. And then I just ran a script that went through that list. Not very efficient, but the reason why I designed PyTest in that purpose was if I wanted to say Dockerize it and then launch a bunch of Docker containers, one per device, I could spin up a fleet of containers. Every container was one device, and I could do them all in parallel. Or PyTest actually has a parallel plugin. I haven't played with it myself, but if you actually wanted to try to run multiple tests in parallel, it actually will fork itself and do that kind of parallel action. But to answer your question specifically, one invocation equals one device, and I wrote a bash script to iterate through it. So it's kind of simple and cheap and easy. But I'd launch it in the morning, grab coffee, and then I'd have my spreadsheet, ready to go. So good question, though. Yes.
So Ansible is kind of a big thing, right? People are flogging it, maybe more than they should. And I've had a lot of people come to me and say, well, you should use Ansible for this. So not only to pull the stuff off your devices if you don't have something like the EOS API, but put all your test logic in Ansible and then use it to call other things to analyze your output and stuff. You clearly have a different philosophy. Can you talk about maybe how those fit together in the case where you don't have a nice router API you can call directly from Python?
Yeah, absolutely. Can I get the video back up for just a sec? Yeah, thank you. So it's exactly, your question exactly is the reason why I compartmentalized the verification functions. And I actually have a friend of mine who took those functions and turned them into Ansible modules so that Ansible could then gather the actual data. It was collecting the data, and then they wrapped this library as a series of modules. And then they could use Ansible to drive the collection and execution in a way replacing PyTest. But there was logic that they would have to build in to iterate through every single test case. And there was a reason why perhaps they wanted to do it that way. But that library that says PyTest really isn't, and that's why I said it's a misnomer and I'll fix it. And it could be used, invocation you'd have to still wrap an Ansible, their Ansible module mechanisms around it. But it's a very fair approach. There's nothing wrong with that approach. Yeah, so I'll just stop there. Yep. Thank you.
I'm sorry to jump in. Actually, I think it's, I personally tried, and I think it's the wrong idea to use Ansible for that, because their default strategy is that you will have, a list of tasks that will be executed per device, but the first one that failed, it actually doesn't execute the next one. So unless you actually explicitly say, keep executing and all of that, and the reporting is actually absolutely not designed for this use case. So personally, I think there's a lot of use cases where Ansible is great, but I personally try to use that for testing, and I think it's not a good one. Like somebody was saying on Twitter yesterday, you really know a tool when you know when not to use it. I used it for that, and I will not use it anymore.
Yeah, it's fair, and I don't disagree with many of the things that you both said. So. Yeah. Other questions? Yeah. Go.
Hey,
Yeah.
Kat with Apple. So I'm curious how you built your expected results. Was that all by hand for those 300 devices?
No.
For what you're planning to build it out as?
Yeah. So I'm going to give you two answers. The answer that I would recommend people to do is you have some source of truth. For example, that spreadsheet. And then you programmatically use that as your input to generate your test case output, right? I happen to have a very sophisticated piece of software that is the design of my network that is a graph model database. And from that, I know what those relationships are and what I want to validate. For example, I know my BGP peers, I know my MLAG interfaces. I have a lot of very context-aware knowledge, and I'm using a database in order to extract out the relationships. It's that database that actually produced that spreadsheet, right. For example. But there are many tools out there that you could use, that aren't like roll your own database like Mr. Jeremy did. Like Netbox, for example, if you're using Netbox, and I think it's a very popular source of truth thing, it actually can give you some of this information. You could pull from its APIs, or if you're buying a vendor product and it has topology information, you could pull from it. So, I don't know, did that answer your question?
Yes, it did. I was mostly curious because it's depending on which egg you have first, that database can then become the rest of your chickens for your patch plans and your as-builts and your topologies.
I subscribe to that newsletter. From when you saw that design, build, deploy, operate, which is a very common pattern and a theme that you'll see in every single vendor product or platform piece of technology. The design part is, have some database that represents your network design. And from that, you can build your configs, you can get your test cases, you could build the artifacts like your cabling map, all sorts of things. So, but it's a very large investment if you're trying to build it yourself. There's a couple products on the market that are worth looking at that are very specific on their use cases. But unless you have the right kind of engineering, it's hard to do. Yeah, for sure.
Thank you.
Yeah, thank you. Good question.
Just a quick follow-up to that question is, does PITest provide an infrastructure to compare test results? For example, sometimes it happens like I upgrade my code and did a convergence test, and suddenly the convergence number are way beyond what it was result as a test before run, right? So is there a way we can compare test results, say it's a pass or a fail criteria?
You mean like previous tests?
Yes.
It does, actually. It's an interesting question, one that I have not explored a lot, but in a recent version of PITest, they introduced this concept called a cache, which what they use it for, how they advertise its use is, I only want to run tests that failed the last time. So it's sort of like, I don't want to rerun all my tests, I only want to run the tests that failed. And they have this cache mechanism. So it's possible to exploit or take advantage of that technology in order to achieve the goal you just talked about, because I think it's a very similar pattern, but right. I haven't tried it myself. It's on my list of like next things to try.
Right, because there's definitely not a pass and fail criteria. It's just like my convergence numbers increase, right? So how do you quantify it as a test fail or pass, right? Something like that.
Yeah. So there's something that I didn't show you guys, which is how do I take the failure information and then use that to then segment it into errors and warnings and info, right? And I didn't show you that because I felt that I was going to run out of time, and that little piece is actually pretty another interesting little trick, right? Okay. But through the use of their cache and through the use of, and I'll show you to you since you asked, just so you have something to look up, one more thing to look up. There is, nope, I don't have it on my fingertips. I'll show you after.
All right, that's fine.
Yeah, but I would look into their cache. Like they have this thing called a cache, and I think I actually want to try to take advantage of that myself.
Sure.
Yeah.
Sure. Thank you for the excellent presentation.
Yeah, thank you. Other questions? These are good questions. All right. Does anybody, want to try doing this? Like, just yeah. So, this is not too scary. It's like, I know this is a lot of material. I really do. It's, I was a little concerned that this was going to be, a lot of material. But again, it's recorded. You'll have access to the presentation. You'll have access to all the references. I've had people come up to me after they've seen some of my other presentations, like months later, and they start trying it out. So I do hope you do give it a try. Yep.
Yeah, I have a question. So this seems to be all pass-fail, right? Everything has to be, it matches or it doesn't. Is there any way to turn this into some type of, value gathering device? I want to know, what the optic levels are. I want to know, like that, instead of just, is it right or is it wrong?
Yeah. So I don't know if you were in.
I mean, that's an issue we have with some of our testing, is like some of the things just don't fit into pass or fail, so we might have to go, is it within this range, which is sort of good, but we'd really like to know some value sometimes.
Okay, so I'm gonna answer that question two different ways. So one way is harvesting data and putting it into a data store. I don't know if you sat in on Damien's presentation earlier about gathering telemetry and sticking it into a database, but that that's part of your answer, which is if you want to constantly gather telemetry and stick it in a database, and even in a time series database to look over at time, that's half of the equation. The other half of the equation, because that's your actual data. The other part of the equation is validating the information as a criteria, right? Meaning, you're going to set up that criteria. Here's the acceptable range. Did it pass or fail? Or maybe I'm going to look at this range and I'm going to categorize it as, kind of red, green, red, yellow, green. Like red, this is really bad. Yellow, you should keep an eye on it. Green, it's okay. And since two of you have now asked the same question, I'm going to, give me a sec. I'll pull up this piece of code. What it allows you to do is it says after a test case is executed and you get test, passed, or failed, what do you want to do next? And that's how I generated the, is it an error, is it a warning, is it a whatever. You would use that same exact technique. So let me bring that up and I'll show it to you really, really quickly. Okay, so inside of, this is like super advanced stuff. Okay, inside of your global conf test file, this is what you want to do. You want to add a hook called PITest run test make report. Now, all right, just hang with me for a sec. What this little piece of magic does is it says, before you run this hook, run the built-in hook to gather the report. Okay, so that's really important to do, right? So it's going to gather the actual report, and then it's going to run my function, right? And in here, I'm going to get the outcome of the test. Did it pass? Did it fail? This is how you do this. You basically say, give me, the yield says, give me what the test result was. And now you have this outcome, which you get via this mechanism here. From that report, you say, when the report was called and the outcome was failed, at this point, what you would do is you would look at the failure and make a determination on what to do next. For example, in my case, was the cabling error, was the cabling test case failure an error, or is it a warning, or is it a to-do? So I'll show you how I do that. So this is a function that got called by that other function. Just hang with me there. So what this is basically saying is I actually get the exception that was trapped. Like, because when I ran my test case, I got an exception. So now I know what that exception is. And so if the exception happened to be a missing error, I'm going to turn that into a to-do. If it was a mismatch error, and in this case, if the actual data was localhost, it meant that I haven't ZTP'd this box yet, and so the management probably isn't hooked up yet. So this was like, hey man, you might want to check your management port to the other device because your management interface isn't up. Or maybe this is an error, it's actually cabled to the wrong place. So when I was talking about earlier about crafting your own custom exceptions, you can use that in order to then generate your own custom reports. Yeah, and in this case, what I was doing is I was just saving this to a CSV file. That's my punch list. But you could write that into a database. You could do whatever you want. This little piece of magic here, this run test make report, this is not in the demo, the tutorial demo, because I just thought I was going to run out of time. It's recorded here. I'll probably try to move this example into the, yeah, for sure. Yeah, it's another hook function. The PITest docs, if you go there and you look for hook functions, I went kind of archaeologically exploring what all these things do. So some of them are documented really well, and then I try to Google them to see what they did. And yeah, this is actually really cool. This is how I ended up making those CSV files. Yep. All right. Yes, next question.
Yeah, Jessica Monsley from Lower Colorado River Authority. Do you use this as kind of even a repository with your designs to say, hey, we issue this, or we use this with future design as well? So if you're making changes to the network, you're adding new things. You're saying like this is brownfield. So are you issuing this and using this when you do that addition as well?
Yeah, that's a really excellent forward-looking kind of question. So if you're the kind of company that can have the discipline to maintain your design in a database and keep that up to date, and that is your source of truth, meaning your CLI and your network device is no longer your source of truth, but everything comes from your design, whether it's a collection of spreadsheets or it's a fancy database. As long as that becomes your source of truth, then you can always programmatically then recreate your set of test cases from it. So if you can have that kind of discipline, props, because that's hard to do without having a really easy tool for people to use. But I think that is kind of the answer to this question. I think that's the right thing to do. And one of the next things that I'm looking at maybe giving a talk on is how to implement a lightweight version of that using like Google spreadsheets, just because that's something I see a lot. So, doing graph databases is really, really cool. Not everybody wants to do that, right. But spreadsheets, we can do spreadsheets, and if you keep your spreadsheets up to date, then yeah, that's a way to do it. But you have to be disciplined. You have to get off of the CLI. You have to get, you've got to pry the CLI from, their cold dead hands of, right. Yeah. But I do think it's the right thing to do. It's just hard.
One other question. So is this tool able to be used for from operations standpoint, like, hey, let's just check everything, nothing's gone on when there's an incident or anything like that? Is it reasonable to expect this to do that, or sure. Is it just, hey, don't worry about it?
Yeah, it's all how you kind of plumb that workflow. For example, we use Slack at MLB, and I wrote a Slack bot that the operations guys can do a Slack command, and they can run tests or do things. And so, but the back end, after they hit that command, could then invoke PITest, run its stuff, and give them results. So it's all about, for a lot of folks, it's all about the user experience, whether you do it with, like, say, ServiceNow as a front end, or you use Ansible Tower as a front end, or you have some front end. Most of the time, people don't want to type PITest, they don't want to, do the crafty command line. You have to give them a more consumable user experience. But absolutely, I think it's a great idea. Okay. Yeah. Yeah. All right, 5 minutes. Other questions? All right, we're really clocking right on time. Thank you so much for hanging out with me. I only lost like 50% of the audience. I thought that was pretty good. I was actually worried, so thank you.